Let's talk about RDDs in Spark in more depth. It's kind of the core of Apache Spark, so understanding that is really important. RDD stands for Resilient Distributed Data Set, and just like it sounds, it's an abstraction across all the nastiness that happens under the hood in Spark to actually make sure your job is evenly distributed across your cluster, that it can handle failures in a resilient manner, and at the end of the day, it just looks like a data set to you. So these RDD objects are just sort of a way of storing keys and value information, or just any information in general, in an object that can automatically do the right thing on a cluster. So from a programming standpoint, an RDD is just a data set to you, but under the hood, it's resilient and distributed, and you don't have to think about that very much. How do you make RDDs? Well, your driver program's going to create something called a Spark context, and that's basically the environment that you're running your RDDs within, and it will create your RDDs for you, and from those you can do stuff with them. So there's actually a Spark shell you can run interactively that creates an object called SC for you, or you can explicitly create a Spark context from a standalone script that you can run, on a schedule or what have you. So the Spark context is sort of the environment that your driver program runs within in Spark, and it is what creates RDDs that you start with. Creating an RDD can be done in many different ways, so if you're just fooling around, you can actually explicitly create an RDD from a given list of values. So if I just wanted to make an RDD called nums, I could call parallelize with the array 1, 2, 3, 4, and that will create an RDD that contains the values 1, 2, 3, and 4. And I could then do stuff with that RDD, and it would, in theory, distribute it across an entire cluster, although in reality, for something that small, it wouldn't. Now, that's really not very useful in a practical sense, because if I can fit all of my memory in my script, then I didn't really need to distribute it in the first place, right? And we're not talking about big data if I can just stick it in a call like that. So good for fooling around, but not real useful in practice. What you'll do more often is actually load up an RDD from a given text file. And in this example, it's just sitting on my hard drive, but you can also refer to that from an HDFS file system. So you can actually load up a huge file that's broken up into blocks distributed across an entire cluster on HDFS. If you're using Amazon Web Services, you can also use S3N URLs to actually load data from Amazon's S3 service, and so on and so forth. And that will load up all of that data into a new RDD that's returned by text file, and that will contain a line of input text on every row of the RDD. Once you have that, you can also create one from a Hive context. So we haven't talked about Hive too much. We looked at it briefly at the beginning of this course, but you can also create a RDD from Hive, and then you can actually just do SQL queries on the Hive context from within Spark. So sort of an alternative way to using Hive. And you can also create RDDs from any database that's connected to JDBC, from Cassandra databases, from HBase databases, from Elasticsearch, from actual structured data files like JSON or CSV or sequence files or object files, and all the different compressed formats that Hadoop supports. So basically, you can create an RDD from big data from pretty much any data source that you can dream up. Spark's very extensible in that way. Once you have an RDD, what do you do with it? Well, if you think back to MapReduce, you can think of it in terms of mapping and reducing. For one thing, you can call map on your RDD, and that will apply some function to every input row of your RDD and create a new RDD that is transformed in some way using map. Now, map is used when you have a one-to-one relationship, when every input row of your RDD maps to an output row of some new RDD. But sometimes you want a different number of rows in the output. Maybe you want to split out each input line into multiple rows, or maybe you want to discard some of the input lines if they're invalid. Flat map does that for you. So the difference between map and flat map: map has a one-to-one relationship between the input and output. Flat map can have any relationship where your input lines may or may not result in one or more output lines in the resulting RDD. This will make more sense when we look at an example, okay? So I'm just kind of putting these ideas in your head right now. Filter can be used to take stuff out of an RDD, so you can provide that with some function that determines whether or not a row in your RDD survives in the resulting RDD. Distinct does what it sounds like, just gives you back the distinct, unique values in an RDD. You can also sample them randomly, and you can combine RDDs together using operators like union or intersection or subtract or Cartesian product. So a lot of stuff very similar to what you were doing in Pig, but Spark again is a little bit more powerful. Let's look at some example code here. So let's say that we want to just do a simple example of taking an RDD of integers and squaring them. So all you would do is once you have your SC object for your Spark context, you can call parallelize 1, 2, 3, 4 to create a simple RDD that just contains the values 1, 2, 3, 4. So at this point, we have an RDD where each row, think of it as a little miniature database, contains one column, 1, 2, 3, and 4. We call map on that RDD with what we call a lambda function. And this is just a way to apply a given function in one little compact line to your RDD. So this is saying, take each input row from RDD, call it x, and then return the value x times x into the resulting RDD called squared RDD. So what's going to happen here is it's going to go through each row of RDD, start with a 1, we're going to call x1, and it's going to return 1 times 1. So the output into squared RDD will be 1. But then the second row comes in 2, we assign 2 to the variable x, and return 2 times 2, which returns 4 into squared RDD. Let's do this one more time. Let's say we go to the third row. 3 will then be assigned to x. X times x is 3 times 3. That gives us back the number 9. Now, if you're new to programming, that might take a little bit of wrapping your head around, but if you've done any scripting or programming before, then this is pretty trivial stuff. The main concept here that might be new, though, is this functional programming here, where we're actually defining a function in line. This is basically a function that says, take an input value x and return the value x times x. So we have this little compact representation of saying, here's a simple function. I'm actually specifying this function as a parameter to the map function. So at a high level, that's all functional programming is. It's pretty easy to understand when you look at an example like this, but big fancy term, functional programming, that's what we're doing here. Let's talk about that in a little bit more depth. So in Python, the syntax for this functional programming paradigm is the lambda function. So we can say lambda x, x times x. And that is exactly the same thing as saying, defining an actual function called square it that takes an input of x and returns x times x. So in Python, this is what a function looks like, and we could just pass in that function name to our map function and it would do the same thing. Okay, so if you have sort of a one-liner function, you can use this lambda notation to do it without actually writing another function. But if you want to do something more complicated, usually you're going to actually write a function within your script that transforms that RDD and pass in the name of that function to your map call on the RDD. Okay, and that's all functional programming is. It just means you're defining functions that can transform things and specifying those functions to things like map. Not that hard. More things you can do in RDD. So we were talking about transformations in RDDs, ways you could actually take one RDD and turn it into another. And that's analogous to the map function of a MapReduce job. But what if you want to reduce? What if you actually want to crunch the numbers down? Well, that's what the actions do. So collect will actually just take the input, all of the results of an RDD and suck them down to the driver script. So make sure that at that point you've reduced your results down to something that can fit in memory. Collect will basically take whatever's in your RDD and return a Python object that you can then do whatever you want with from your Python driver script. Print it out, save it to a text file, what have you. Count will actually give you back a count of how many rows are in the RDD. Count by value will actually give you a tally by each unique value in your RDD and how many times each value occurs. Take can be used just to take, for example, the top 10 results or whatever. Top, same idea, just returns the top few rows of an RDD. So if you just want to be, these are useful for debugging. If you just want a little quick view of what's in an RDD at a given point, take and top are a good way of just taking a little sample from those RDDs so you can confirm that it contains what you expect. And reduce does what you would expect. It allows you to define a function to actually combine all the values associated with each unique key, just like you would do in MapReduce, and more. And the important thing is that in Spark, nothing actually happens in your driver program until one of these actions are called. So nothing will actually kick off within your driver script until you call one of these functions on an RDD. And at that point, you're basically telling Spark, okay, this is the result that I want to get out of this RDD. And that's when Spark can say, I'm going to work backwards from that result and figure out the fastest way to achieve that result that you want. So basically, as you're going through this script and transforming your RDDs, until you hit an action, all that's doing is building up this graph, this chain of dependencies within your driver script. And only when that action is called does it actually figure out the quickest path through those dependencies. And it's at that point that it actually kicks off the job on your cluster. Now, this can be confusing when you're debugging things because Things don't really happen until you actually call one of those actions, and you need to keep that in mind. But that is one of the main secrets to Spark speed. So with that, let's talk about a real example of using an RDD to solve a real problem. Enough talk. Let's get some action and actually write some code. We'll do that in our next lecture.